Hi Year 10. So our first learning intention is about drawing quadratics using a table of values. Before we go straight into that, let's just have a chat about what is. So now, if we're going to draw them using this table of values, how do we do that? Well, we have this equation here that we want to draw, and I'm just going to write it over here so you can see my working out. I've got y equals x squared plus 2. Then up the top here, I've got a whole lot of x values. Remember when you're plotting a point on a graph, so say I plot a random, I've got x values here and y values here. So if I want to put the coordinates of that point, I put the x value, so the x value in this case is 6 down here, and the y value across from here is also 6. All right, so I'm going to put 6, 6. That's the coordinate of my point. So when we've got y equals x squared plus 2, and we've got an x value, that means we can find a y value. So my x value up the top here is -6. That's that x value. All right, so I want to find the y value. So I'm going to put -6 into this equation. Let's do that. So y is going to equal -6 squared plus 2. Now you'll notice that I put the -6 in brackets. That's because the whole thing is squared. It's not just that the 6 is squared, the whole is squared, negative is also squared. If you put that on your calculator, you'll get 36 plus 2, which is 38. Okay, so we know that the y value there is 38. Then I'm going to do the same thing again, but for -4. So -4 squared plus 2. Again, pop that in your calculator or you'll get 18. And then we keep on doing the same thing. So I'm not going to write them all out here, but you can probably work it out. So -2 squared plus 2, it's going to be for this one here. It's going to be -2 squared plus 2, which is going to be 6. And then I'm going to get 2, and then I'm going to get 6, 18, and 38. Now you might be saying, how did you work that out so quickly? Well, it's actually because you'll notice that the value for -6 is the same as the value for 6. The same value for -4 is the same as the value for 4. And that's the cool thing about quadratics. When the x coordinate right here has the same size, so for example -6 and 6, they've got the same size. They've got different signs, but they're the same size. When they've got the same size, they're going to have the same y value. All right, now we have to work out how to draw it, and we look at it and we go, well, we're going from 38 to 2 on my y-axis. Obviously, I can't actually fit that in there, so I'm going to have to change this axis a bit. My x-axis is fine, but I'm going to have to change the y, and that's perfectly fine. Okay, so let's talk about the important things when you're putting a scale on an axis. The really important thing is that the numbers on that scale are evenly spread apart. So I'm going to start at 0. Then I'm going to go out by 2 and see that I've got the same on both sides of that axis. I've got -2, -2, go out by 2 again. The distance between 2 and 4 is the same as the distance between 0 and 2 because it's the same distance. It's a distance of 2. And obviously when you're doing that on a graph paper, it's going to be easier. So there's my x-axis. Now my y-axis, I want to go all the way to 38. So I've got to fit a lot of numbers in here, in there. So I'm going to start really small down the bottom with 4. And then I'm just going to go up by those so that I can fit it all in. Go up by 4s, 4, 8, 12. You could go up by 5s. Doesn't really matter as long as you've got this even spread. 20, 24, 24, 28, 32, 36, and 40. So let's plot our points now. We've got -6 and 38. Well, -6 is over here in your x, and 38 is going to be between 40 and 36. So I'm just going to plot a point in between there. All right. Now I'm going to plot Quadratic. Quadratics are just something which are of the form, if you wrote out the equation for them, y equals ax squared plus bx plus c. Now the a, b and c are just numbers. And I would really think this would be a good idea to write this in your glossary. So a, b and c are numbers. So for example, we could have y equals 2x squared plus 3x plus 5. Or if you were feeling lucky, you could have y equals 8x squared and not have an x term and a c term. That's fine. The thing that makes it a quadratic is because it's got the squared bit. It's got 8x squared. Okay, so that's what makes it a quadratic. Another one would be y equals 5x squared plus 4. So you've got the c bit right there, but you don't have this bx bit. That's absolutely fine. You don't need it. The thing that makes a quadratic is the squared term. Then if we drew graphs of that either look like this thing here or this thing here, they're both quadratics. If the number in front of the x squared is negative, they'll look like that. This one here. If the number in front of the x squared is positive, it'll look like that one there. But you don't really have to worry about that now. That's just to get the idea of what the shape of a quadratic looks like in your head. Yeah.